Already you have known that in case of discrete random variable, we define probability distribution function, and it is defined as Px is equal to P of x is equal to x. Here Px is probability distribution function, and value of random variable, this is equal to probability that the random variable x takes the value small x, real number. And in case of continuous random variable, we define probability density function. In case of continuous random variable, we define probability density function, and which when integrated, when we integrate the probability density function over the interval a to b, then we obtain the probability of that the random variable x takes the value on the closed interval ab, and that is probability that x fall within on the interval ab, and x fall within on the interval x ab is the probability pa less or equal to x less or equal to b, and this is the integral of probability density function. Here fx is probability density function. Probability density function. So these are the two concepts, and in case of discrete random variable, we define probability distribution function, and in case of continuous random variable, we consider probability density function, which on integration over the interval ab gives the probability such that x fall within on the interval ab. Now we will discuss one by one. Consider discrete. Previously already we have studied discrete distribution and uniform distribution, and their mean standard deviation variation, and mean variance and standard deviation. Now again, why we want to study these two distribution? Actually, now we are going to discuss continuous uniform distribution and uniform discrete distribution, uniform discrete distribution and uniform continuous distribution. Both uniform, and if previously here the probability of each of the event was not same. For example, suppose we toss a coin, and then the random variable count the number of head 2 times or 3 times, then the probability of coming the head, 1 head, 2 head, no head, all are not same, and that is this distribution is not uniform, and the probability of each event are not same. So now we consider the uniform distribution, and that is suppose the probability of happening of each and every event is same. The random variable may be discrete or may be continuous. So first consider discrete uniform distribution. Discrete uniform distribution. Suppose if the random variable has only finite number of value, if it has infinite number of value, then it will be continuous. So, and suppose the random variable has only finite number of values, and the probability that the random variable takes these finite value are same. Any probability, and suppose the value of the random variable are x1, x2 and xn, then the probability that the random variable x takes the value x1 is same as the probability that the random variable takes the any value x2, xn and x2. Probability of any two event is same, and that is each of which can occur with equal likelihood, and that is the probability of occurrence of each of the event is same. So in that case, the distribution is known as discrete uniform distribution. Here value of the random variable are discrete, but the probability that the random variable takes this value, that is the probability of occurrence of each of the event is same, then this distribution is known as discrete uniform distribution. Let the value of the random variable are x is equal to 1 to 2n, यानी x1 x2 xn के बजाय हम पर्टिकुलर फिक्स कर दिए 1 to n. In this case, और ये एज्यूम करके चल रहे हैं कि द डिस्ट्रीब्यूशन इज डिस्क्रीट यूनिफॉर्म डिस्ट्रीब्यूशन, दैट इज प्रोबेबिलिटी ऑफ अकरेंस ऑफ ईच इवेंट इज सेम. So in this case, the probability distribution function is given by Px is equal to 1 upon n. The probability of occurrence of each event is same. So this probability will be 1 upon n for every n, and x is equal to 1 to 2n. Then the mean and variance. Then the mean is, we know that xi into pi या pxi. So this is equal to, here I is equal to 1 to capital N. So then this value कितना आएगा? This will be 1 into 1 upon n plus 2 into 1 upon n dot dot plus n into 1 upon n. So this is equal to 1 plus 2 plus 3 plus n into 1 upon n comma, and this is the sum of n number, the n plus 1 by 2 into 1 by n. So this is equal to n plus 1 by 2. The mean of discrete uniform distribution is given by n plus 1 by 2. N is the number of values of the random variable. Variance, similarly we can find the variance. The variance will be variance of x, this is equal to summation xi square pi minus x bar square, and this is xi, and that is 1 into pi 1 upon n plus I xi1 to 2 into 1 upon n, 2 square plus 3 square into 1 upon n, and so on. अब इसको सिंप्लीफाई कर लीजिए, एंड दिस माइनस एक्स बार स्क्वायर, और ये लास्ट क्या आएगा, एन स्क्वायर इंटू 1 अपॉन एन, दिस. अब ये आएगा आफ्टर सिंप्लीफिकेशन, दिस विल बी and 1 upon n taking common, so it will be 1 square plus 2 square plus 3 square and so on up to n square and 1 upon n. Sum of square of n number, so using this it will be n plus 1 and 2n plus 1 divided by 6 into 1 upon n. So this n cancel out and minus 1 upon n का स्क्वायर. तो फाइनली नॉट n स्क्वायर, ये x बार कितना आया सारी, x bar is n plus 1 by 2, तो n plus 1 by 2 का स्क्वायर, दिस, तो माइनस n plus 1 स्क्वायर by 2. तो फाइनली इट विल बी n स्क्वायर माइनस 1 अपॉन 12. इसको आप सिंप्लीफाई कर लीजिए, तो दिस विल बी द वेरिएंस. स्टैंडर्ड डेविएशन निकालना था, अंडर रूट वेरिएंस आ जाएगा. तो these are the mean variance of discrete uniform distribution. Discrete distribution जब पढ़े थे तो वहां पर अलग चीज था, but here discrete in this difference between discrete distribution and discrete uniform distribution is in discrete uniform distribution we assume In case of discrete uniform distribution, we assume equal probability for each event, and that is each event occur equally likelihood. The probability of each event are same. But in case of discrete distribution, this is not same for every event. This is the main difference. So why we are considering this? Actually, this discrete uniform distribution has great application. With the help of this, we can study many other distribution. For example, the Bernoulli distribution. In Bernoulli distribution, we consider only two possible outcomes. Suppose we toss a coin and the coming head is considered as success and coming tail is considered as failure, then the probability of coming head in tossing up a coin is same. And 1 by 2, coming head or not coming head, 1 by 2. So if the random variable can take only two values, 0 and 1. If suppose we assign 0 for the failure and if we toss a coin and coming tail is considered as failure, then we assume the random variable takes the value 0 and coming head is suppose considered as success. So in that case we assign the value to the random variable 1 and that is suppose 0 is for failure and 1 is for success. Then probability, if suppose probability of success is P, then probability of failure is Q. So then P plus Q is equal to 1. Probability of success plus probability of failure is equal to 1. And this is known as Bernoulli trial. This is known as Bernoulli trial. If the outcome of an experiment is only either success or failure, success is considered as 1 and failure as 0, then this is known as Bernoulli trial. This distribution has no direct application, and the Bernoulli distribution has no direct application. But with the help of this, we can develop a number of distribution. This Bernoulli trial has no direct application, but with the help of this, we can develop many distribution. For example, binomial distribution, Poisson distribution, another. So now consider binomial distribution. And if we perform Bernoulli trial means, and if we perform an experiment in which only two outcomes, either success or failure, and if we repeat this experiment n time, if we repeat this experiment n time, then this is known as Bernoulli distribution. This is known as Bernoulli distribution, and this is given by Bernoulli in 1713, and this result was published after 8 years of his death. Actually, when he submitted this work for publication, then the reviewer rejected, and after his death, 8 years of his death, again someone published this work with his name, and it is so popular now. The Bernoulli trial if we perform a series of experiments in which the only outcome is either success or failure, only two outcomes, either success or failure, then the experiment is known as Bernoulli trial. And in this case, we assume the random variable takes the value 0 for failure and 1 for success. So now, if suppose we repeat this experiment n time, and that is we perform Bernoulli experiment n time, and we toss a coin n time, and here only outcome is either success or failure, only two outcome. Then the probability of our success is given by, and if we perform Bernoulli trial n time, then the probability of our success is given by PR. This is equal to NCR P to power R Q to power N minus R, where P plus Q is equal to 1. And the probability, if success is 1 and failure is 0, the sum of these two, probability of success, probability of failure, is 1. Suppose we toss a coin one time, so either head come or tail come. This is the sample space. The coming head is probability 1 by 2, coming tail probability is 1 by 2. The sum of these is 1. This is P and this is Q. Actually, Q is equal to 1 minus P. Q is equal to 1 minus P, or P is equal to 1 minus Q. So then, if we perform Bernoulli trial n time, then probability of our success is given by this formula. This is the probability distribution function for Bernoulli binomial distribution. So here Bernoulli distribution, so only suppose we toss a coin, coming head is considered as success and coming tail as failure, only two possible outcome. This is known as Bernoulli trial. And if we repeat this experiment n time, then the probability of our success is means, and if we toss a coin n time, and then out of these n time, r time head come, its probability is given by this, where P plus Q is equal to 1 and R is the number of success and N is 1, 2, 3 and so on. So here R is equal to 0, 1, 2, मैक्सिमम वैल्यू कितना होगा, n टाइम टास्क कर रहे हैं कि यानी all the n time we obtain success, so then R is equal to 0, 1 to n maximum. Now with the help of this we can calculate probability of 0 success, and NC0, P0 and Q n minus 0, that is this will be Q to power n, and probability of 1 success NC1 P Q to power n minus 1, and probability of 2 success NC2 P square Q to power n minus 2, and so on. Probability of n success, that will be NCN P to power 0, that is 1, and Q to power P to power n होगा, P to power n Q to power 0, that is P to power n, probability of n success. This now the consider these terms q to power n, nc1 p, q to power n minus 1, nc2 p square, ncn equal to p to power n. So here probability of 0, 1, 2 and n success are nothing but these are the term in the binomial expansion of q plus p to power n. And if we consider the binomial expansion of this, then we obtain what? nc 0 q to power n p to power 0 first term, and second will be nc1 plus nc1 q to power n minus 1 p, and so on for nth term ncn and q to power 0 1 p to power n. You see, these are nothing, these are the term first, second and n plus 1 at term. First, second and n plus 1 at term in the binomial expansion of q plus p to power n. So this is binomial distribution. For binomial distribution, probability distribution function is given by this, and with the help of this we can calculate the probability of our success. Now consider the mean and variance of this distribution. The mean and variance. To find the mean and variance, suppose we form a table. Here, suppose we denote d by n minus 0. Only symbol, or directly we can write the value of the random variable. So d is equal to, actually this is the value of random variable minus 0. So d is 0, 1, 2, 3 and so on and n. These are the value of the random variable. And then suppose f is the probability of 0 success, 1 success, 2 success and n success. This is first term is here probability of 0 success q to power n, q to power n, probability of 1 success nc1 p q to power n minus 1, nc2 p square q to power n minus 2, nc3 pq q to power n minus 3 and so on, and this will be p to power n. Now suppose here we consider total in this row. The sum of f, this is the q plus p to power n, कितना हो जाएगा 1. You see here these are the binomial coefficient in the expansion of q plus p to power n. So q plus p is 1, so 1 to power n, that is 1. Sum of this column. And next, if suppose we consider f into d, this will be 0 and this will be nc1 pqn minus 1, then 2 into nc2 p square qn minus 2 and 3 into nc3 pqn q to power n minus 3 and so on, then n into p to power n. Now suppose we consider sum of f into d. This will be, you can see this will be n into p. So this is mean, and mean is sigma f in sigma xi and p. So here p is denoted by f and xi denoted by d. So this is mean. The mean of binomial distribution is n into p. And again consider one more column. F square d, sorry d square f होगा, d square f. So it will be 0 and 1 square into nc1p q to power n minus 1 and 2 square nc2p square q n minus 2 and 3 square nc3 p cube q to power n minus 3 and so on, n square into n pn, npn नहीं होगा, sorry, n square into pn. This. Now suppose if we consider sum of this sigma f d square, then this will be np into 1 plus p n minus 1. This. The mean of binomial distribution equal to a plus sigma f d upon sigma f. So this is equal to, here a is assumed mean, in general we consider assumed mean 0, so 0 plus sigma f t, here np, and upon sigma f will be 1, that is np. The mean of binomial distribution n into p, p the probability of success, and variance we can calculate variance by using the formula. To variance of binomial distribution. So this is equal to summation x square, क्या होता है पी आई माइनस एक्स बार स्क्वायर, तो यही यूज करना होगा यहाँ पे. तो दिस विल बी सिग्मा एफ इंटू डी स्क्वायर अपान सिग्मा एफ लिख सकते हैं, नहीं भी लिख सकते हैं, माइनस सिग्मा एफ डी मीन अपान सिग्मा एफ का स्क्वायर. ये तो यही है, दिस एंड दिस. यहाँ नहीं लिखा गया है, आप लिख सकते हो सिग्मा पी आई. तो दिस इज इक्वल टू, अब इसकी वैल्यू जो आया है सम ऑफ एफ डी स्क्वायर, सम ऑफ एफ डी स्क्वायर इज दिस एंड माइनस दिस. तो दैट इज इट बिकम एन पी इंटू 1 प्लस एन माइनस 1 पी, दिस टर्म वैल्यू माइनस मीन स्क्वायर, तो एन पी का whole square. Then this is equal to, अब देखिए NP कॉमन है तो क्या आएगा, NP कॉमन, देन N minus 1 P plus 1 minus NP. So this NP will be cancelled out and this will be minus P plus 1. गलत हो रहा है. तो ठीक है, this will be NP into my 1 minus P. So this is NPQ. Since P plus Q is equal to 1. This. So here variance of binomial distribution is NPQ and mean is NP. And standard deviation क्या आएगा? Standard deviation of binomial distribution. This is equal to under root NPQ. This. So here, suppose for any problem is to find the binomial distribution. So then we need to find probability distribution function, that is R may be given PR, and then mean, variance and standard deviation. So if we know these three, so with the help of this we can determine complete binomial distribution, that is value of N, P, Q. Next, recurrence formula. For binomial distribution, we know that the probability of our success in binomial distribution is NCR P to power R Q to power N minus R. And from this formula we obtain probability of R plus 1 success, NCR plus 1 PR plus 1 into Q to power N minus R minus 1. Now consider this relation PR plus 1 upon PR. So this will be NCR plus 1 PR plus 1 and Qn minus R minus 1 divided by NCR P to power R Q to power N minus R. Now see, writing the value of this, the NCR factorial N upon factorial R plus 1 into factorial N minus R minus 1 into NCR, the नीचे factorial N upon factorial R and into N minus R and into P upon Q. This N cancel out and r, if suppose r plus 1 here we take common, so this will become r plus 1 factorial r. So this r cancel out, and here n minus r common, so then this cancel out. So it become n minus r upon r plus 1. This is plus 1 and p upon q. So this is recurrence relation between probability of r plus 1 and r success. If we know P0, probability of 0 success, then we can calculate probability of 1 success, 2 success, 3 success, and so on. Only we require P0, probability of 0 success. That will be NC0 and Q to power n. That is, if we know Q, then Q to power n. कुछ क्वेश्चन करिए. Question is determine the binomial distribution whose mean is 9 and whose standard deviation is 3/2. आपको बाइनोमियल डिस्ट्रीब्यूशन निकालना है. डेट इज आपको क्या निकालना है? एन की वैल्यू एन पी क्यू. मीन और स्टैंडर्ड डेविएशन दिया ही है. ठीक है, तो हियर मीन इज गिवन, तो एन पी इज इक्वल टू 9 इज गिवन, दिस गिवन, एंड स्टैंडर्ड डेविएशन अंडर रूट variance, तो variance is npq, तो under root npq is equal to 3/2 and npq is equal to 9/4 and np here is 9, q is equal to 9/4, the q is equal to 1/4, so p, therefore p will be 1 minus q, and that is 1 minus 1/4 to 3/4 this. तो बाइनोमियल डिस्ट्रीब्यूशन इज, n की वैल्यू अब कितना आएगा? p निकल गया, तो n p, हाँ यस, हेलो बोलिए.
12.
क्या चीज? हेलो, आवाज नहीं आ रही. क्या बोल रहे हो? कुछ बोलना है?
No, sir.
ठीक है, ओके. तो np इज इक्वल टू 3/4, sorry, np is 9, np is 9, so this implies P is given, n निकालना है, तो n is 9/p, that is 9 and into 4/3, तो 12. तो binomial distribution n is equal to 12, p is equal to 3/4 and q is equal to 1/4. ये भी आप चेक कर सकते हो करेक्ट है या नहीं है. p plus q is always 1. तो दिस इज बायनॉमियल डिस्ट्रीब्यूशन. मींस बायनॉमियल डिस्ट्रीब्यूशन निकालना, तो आपको निकालना क्या होगा, ऑलरेडी मीन और वेरिएंस दिया है इसलिए हम उसकी बात नहीं कर रहे हैं. यानी वी नीड टू डिटरमाइन एन पी क्यू मीन वेरिएंस एंड स्टैंडर्ड डेविएशन. तो ऑलरेडी मीन एंड स्टैंडर्ड डेविएशन आर गिवन, तो इसलिए बात नहीं कर रहे हैं उस सबकी. अगर वेरिएंस निकालना है तो कितना आएगा, वेरिएंस क्या हो जाएगा, एन पी क्यू. तो एन पी क्यू 12 इंटू 3/4 इंटू 1/4, तो 9/4. जो वेरिएंस, हाँ ठीक है, वेरिएंस नहीं दिया, ये भी आप निकाल सकते हो कि वेरिएंस इज 9/4. तो दिस इज बायनॉमियल डिस्ट्रीब्यूशन. तो ऐसे कोई भी क्वेश्चन आप कर सकते हो. नेक्स्ट इज, अभी आप लोग क्लास है
सर, 1 से 2 के बीच में गैप है सर, उसके बाद क्लास है.
ठीक है, तो 5 मिनट हम बता देते हैं दूसरा भी, पाइजन डिस्ट्रीब्यूशन. तो बचेगा नॉर्मल डिस्ट्रीब्यूशन, तो उसके बाद खत्म हो जाएगा. नेक्स्ट वन इज द पाइजन distribution. This is due to Poisson and it is published in 1837. It is the limiting case of binomial distribution. It is the limiting case of binomial distribution. In binomial distribution, you have seen that we have performed the Bernoulli trial with the assumption that there are two outcomes. One is success and other is failure. Always. And the probability of each event are same. But consider the case when n is very large. If n is very large, and probability of success is very small. And suppose if n is very large and probability of success is very small, then the average number of success that is mean Np will be a constant. And if n is very large, number of Bernoulli trial is very large, and the average number of success, that is the mean is very, and n is very large and number of success, the probability of success is very small, p is very small, then average number of success n into p is almost constant क्योंकि n large है and p is a very small quantity. The product, the mean average number of success will be a constant, say lambda. Actually, in case of binomial distribution, it has mean, variance, 2 parameter and depend upon n, p, 2 parameter. But here only 1 parameter, lambda. The discrete probability distribution, in this case, the distribution, discrete uniform distribution is known as Bayesian distribution, and we define the probability density probability distribution function. Probability distribution function, suppose we define x is equal to x and this is equal to e to power minus lambda into lambda to power x upon factorial x. X is equal to 0, 1, 2 up to infinity. Is called the probability distribution function itna is called the Bayesian distribution. With parameter lambda. It has only one parameter lambda. To determine this distribution, we need to determine lambda. So here again we can calculate mean of Bayesian distribution. So is given by summation I is equal to here 0 to infinite xi into pi. So this will be xi here 0, x is equal to 0, so then it become 1. First term become xi 0 into pi, pi become e to power minus lambda, lambda to power 0 upon factorial 0, so 1 plus 1 into e to power minus lambda, lambda upon factorial 1 plus 2 into e to power minus lambda into lambda upon factorial 2 plus 3 into e to power minus lambda into lambda upon factorial 3 and so on. Now you see here lambda e to power minus lambda is common. So it become 1 plus lambda plus lambda is common, lambda नहीं आएगा. Here e अच्छा एक मिस्टेक हुआ है. Here 1 lambda square lambda cube. तो 1 plus lambda plus lambda square by factorial 2 plus and so on. So this is equal to lambda e to power minus lambda and e to power lambda. This lambda. So mean is lambda. And similarly we can calculate variance. So variance of Bayesian distribution This is equal to summation xi square pi minus x bar square. I is equal to 0 to infinity. So after simplification, again it will be lambda. Put the value of xi, pi and x bar, and then after simplification you will see this is again lambda. So here we see that the mean and variance of Poisson distribution coincide. And mean is lambda and variance is also lambda. The mean and variance of Poisson distribution coincide. It has only one parameter, which is lambda. Lambda is equal to mean. Now we can obtain the recurrence formula for Poisson distribution. The recurrence relation, as in case of binomial, here again we obtain recurrence formula for Poisson distribution. So we know that Px is equal to e to power minus lambda, lambda to power x upon factorial x is equal to 0, 1 to infinity. And then Px plus 1 can be written as e to power minus lambda, lambda to power x plus 1 upon factorial x plus 1. Dividing these two, x plus 1 by px. So this become e to power minus lambda, lambda to power x plus 1 upon factorial x plus 1 into, इसको रिवर्स कर दें तो ये फैक्टोरियल x अपॉन e टू पावर माइनस lambda, lambda to power x. So here it will be x plus 1 and then factorial x, this will be x plus 1, x plus 1 and then factorial x. So this cancel out and e to power lambda cancel out, and here if we take lambda, then lambda to power x, so this lambda upon x plus 1, and that is we obtain recurrence formula px plus 1 is equal to lambda upon x plus 1 px. If we know p0, then we can calculate here px means probability of x success. If we know p0, then we can obtain probability of 1, 2, 3 and so on success. So this is recurrence relation, and here lambda is mean or variance of Poisson distribution, and lambda की वैल्यू कितनी होगी, np. np is equal to lambda this. तो सेम इसी तरह से यहाँ भी क्वेश्चन सॉल्व कर सकते हैं. एक क्वेश्चन लिख लीजिए. If a random variable has a Poisson distribution such that P1 is equal to P2, find P4 given E minus 2 is equal to 0.1353. by using the value of e to power
Excuse me, sir.
minus 2. Yes.
So it's already 1:10, sir. We have to do our lunch also. We have a next class from 2. Can we
ठीक
conclude
है,
the class, sir?
हो गया हो गया। अब इसको आप
Okay.
कैलकुलेट कर लीजिएगा। प्रॉब्लम इज टू फाइंड P4 विद द हेल्प ऑफ दिस रिकरेंस रिलेशन यू कैन डिटरमाइन। ओके, ठीक है, नाउ यू कैन गो।